All right, thank you for joining us at BSides. We are in the ground 1, 2, 3, 4 talk, and we are here with Robert Paul doing Enterprise Overflow: How Breached Credentials Impact Us All. At BSides, we'd like to thank our Inner Circle sponsors, Critical Stack and Valamail, as well as our stellar sponsors, which include Secure Code Warrior, Paranoids, and Amazon. These talks are being recorded and streamed to YouTube, so if you can silence your cell phones, we would appreciate it. And if we do have time for questions at the end, if you could raise your hand and I'll run the mic to you so that the people listening online will be able to hear your question as well. And with that, let's get started with Robert Paul. Thank you.
All right. Thanks, everybody. So just to start off here, there's the GitHub link for the tool that's going to be released in this talk. But don't worry, as I go through the slides, it'll be there at the end as well in case you miss it. So let's just get started here. As you heard, I'm Robert Paul from NewID. I'm also a USAF reservist. And what we do at NewID is specializing in authentication solutions, really around zero-knowledge proofs and all of that great stuff. So really, my job as the director is heading a project that we call internally Project Nebulous, and this is to research the weaknesses in credentials and authentications for our solution, but also just as a general weaknesses in the industry. So I want to start off today talking about the canonical breach. If you haven't heard about it, it happened just about a month ago, and this is a pretty significant breach, or it could have been if the hacker didn't just deface packages. He had gained he had gained access to about 39,000 packages inside of Canonical, and for those of you that don't know, Canonical runs the Ubuntu operating system. They maintain and develop it. So this could have been a very significant breach, and that could have impacted at least 53% of Amazon Web Services, and probably a lot more than that out there on the internet. But I'd like to point out here that right there is Canonical owned account on GitHub was compromised. So they had a credential base compromised on their account. Someone logged in with password reuse and was able to access those packages and repositories. So Project Nebulous is really our internal research project where we have accumulated leaked data out there since about 2009. And so far, we have about 2.5 billion unique passwords out there. And in all, it's totaling now more than 8 billion unique records. This includes social security numbers, addresses, hashes, all of that. And when we look at the list of data breaches reported on Wikipedia, this contains all of the breaches that has basically a news article associated. That only totals to about 9.7 billion records, and the majority of the data that we've collected isn't actually in the Wikipedia page. So there's actually a massive underreporting of leaked data out there. In 2017, Verizon's data breach investigation report revealed that 81% of hacking-related breaches were caused by stolen or weak passwords. And Troy Hunt, of course, everyone here may be familiar with him. He had found that 86% of the passwords that have been coming out of recent breaches are all previously seen in data. So what that means is there's a lot of password reuse. And I want to point out that in 2019, Verizon's breach investigation report, we have seen that the amount of stolen credentials being used in attacks appears to have gone down. But that isn't really the case. It depends on the industry you're in. For example, if it's manufacturing, that's still as high as 80%. And that's because the scope of their report changed quite a bit, and there's been a lot more breaches and different types of breaches as more and more techniques and vulnerabilities come about. So I'm going to talk a bit about the life cycle of a credential breach, kind of what happens from basically ground zero, which is going to be hackers, of course, compromise an organization through any variety of methods. And then, of course, they're going to gain access to additional credentials. Usually, after they compromise an enterprise or maybe a large network, they're going to gain access to some repository of user credentials or perhaps Active Directory hashes and so forth. And what they do next with this is people assume that they immediately like throw this on the dark web and like start selling it, but they actually don't. What they do is they're going to cherry pick each little piece of data out of that leak and use it for themselves to generate further compromise in networks, engage in fraud or cryptocurrency theft, etc. And they share this data actually amongst themselves, and this is where you can intercept it in something I like to call the cybercrime Holy Trinity, which is going to be Tor, Discord, and Telegram. If you're able to, if you're able to embed yourself in these organizations and these groups, that's where they're at. They're actually mostly on Telegram and Discord. They're not even like hiding or anything. Occasionally they'll be on Tor, or at least some of them are. The more paranoid bunch of them will be, and they share it amongst themselves in order to help them conduct SIM swapping attacks and so on. And only after it's outlived its usefulness to them, it could be months or years later, sometimes weeks later if it's moved pretty quickly. Sometimes someone gets a hold of it and decides to sell it. That's when it will end up on Tor and or any kind of darknet forum, being sold for anywhere from $2,000 all the way up to $20,000. And that's when it gets distributed widely. That's when it gets picked up in the news, and that's when we start seeing big ripple effects of people starting to do anything from credential stuffing attacks or just trying to access users' accounts. So there's different parts in that very first part of the compromise in our life cycle. There's different ways that hackers can kind of abuse that or be able to compromise organizations. And the first one would be like trust relationships with B2B. And for example, Target was actually, everyone knows about that here probably, and they were actually hacked through their HVAC vendor. As B. Krebs here points out, its systems traced back to network credentials that were stolen from a third-party vendor. What had actually happened with the Target hack is an HVAC vendor was compromised through stolen and leaked credentials, and then they were able to just pivot through their network with more stolen credentials until they eventually hit the systems that stored credit card information within Target. The second one, of course, is going to be the shared user base. If someone here has a Twitter account, they probably have a Facebook account. Everyone here has a bank account, probably with like one of 5 banks. So if there's a major breach of like user credentials, say at Yahoo, where 1 billion user accounts alone were breached, people are going to take that and they're going to start stuffing that at other websites like Facebook and Twitter. That's a pretty low-tech solution, but they do conduct these attacks, especially on cryptocurrency exchanges. They've seen huge spikes in fraud after there's been a leak such as Collection 1. And then the third one is, again, what I just talked about is credential stuffing, but it's actually kind of different than the shared user base, because this is just mashing all the data that they can get in its username and password combinations, also called combo listing. You may have heard it like that. And that's when they just try it across your entire network. And this is everything from FTP servers, SMTP servers, anywhere you can take a username and password on your network. They're going to attempt to use combo lists on it. And they've been doing it for quite some time. There's active development with this tool. This one is called Email Combo Lister Slayer. It's a well-known one in Carter forums. They tend to usually use this for fraud, but you can actually repurpose it for kind of arbitrarily blasting at like a whole network. And they always have great like 90s-esque graphics or something. And I want to point out that the words that you always see up here is it's always pointing out that they have fresh lists or the freshest data. And that's because organizations often reset their passwords at set intervals. And so the more recent your data is, the more relevant it is to them. So they're always looking to sell the freshest combo list out there. I'm actually going to demonstrate using our internal data set on how easy it is to generate one of these combo lists. And 2 types of organizations. One's going to be a smaller organization, and the other one's going to be a large enterprise. And so I'm going to go ahead and get that ready for you. that is the large organization here, so I'm going to get a small one. Let's full screen that. So I'm going to go ahead and paste here. So I'm going to pause that, and the domain there that you see is squareup.com. They did the keynote for Black Hat this year, so I'm going to generate a combo list for their stuff just for the heck of it, and output it. There's a variety of command line options there for our internal like red teaming tool, but mostly that I'm going to output them, and I'm doing a wildcard query. I'm just saying, give me everything related in my data related to squareup.com. So I'm going to let that run. Takes a second for it to spin up because it's got to go and query Elasticsearch, and there it goes. So within like half a second there, or whatever that was, I got 394 results containing everything from hashes to PII and all kinds of stuff. And you can see the and right over here you can see the databases this came from. So we got everything from Outro to Dropbox, which is like ancient in terms of leaks now. And we ended up with a total of 225 hashes. So what we're going to do is now attempt to crack them. I'm just going to let that run. So it's going to go and do its thing. And real quick, I'm going to pause that. So every red thing there is a plain text credential. I have it nice and color coded so it's easy to see. And so that's going to come from, obviously these ones are from exploit.in and collection 1. And collection 1 is basically just exploit.in and LinkedIn and Dropbox leaks that have been cracked. So as it's running and cracking hashes, I'm just scrolling up here in the tool to just kind of demonstrate that it's pretty easy to get plain text passwords out of there. And so we already decrypted one hash or cracked one hash. And I really say decrypted because we're not actually cracking the hashes here. What I'm doing is I'm going back over the nebulous data and I'm querying it. Have I ever seen a hash with this before? We basically take all the plain text passwords that are in our data set and hashes that have cracked passwords with it, and then we generate a big rainbow table for a variety of different hashes. And this is everything from SHA-3 to SHA-256, so to NTLM in this, and as you'll see in our later tool. So I'm just going to go ahead and skip way ahead here because it's just going to keep going. There's 200 hashes, and it takes about 3 or 4 minutes for it to run. So eventually, though, there we go. So we could see that on a small organization, we cracked 3 out of the 225 hashes, which isn't very much. But it did yield, even on someone who's mostly cloud hosted and an organization that doesn't have that many people, it yielded 30 unique username and password combinations. On a small target like this, it's not really feasible to really just attack them on their network with it. The chances of a combo list with like 30 combos in it would actually work on their internal organization is small. But when I look at all their GitHub accounts, if I like stuff these into GitHub and Twitter and like anywhere I can think of that they may use, or any of their vendors, then it becomes really apparent that it could get pretty dangerous. You could eventually maybe compromise something related to them, like what happened with Canonical. And then the second scenario here that I'm going to start up is going to be a large enterprise. And this is actually going to be Lockheed Martin Corporation. So every time that scrolls, that's 10,000 results. And it's just going to keep going for a little bit there. And so we queried lmco.com and said, hey, give me all the data on Lockheed Martin. Most of this is all old. This is all stuff from like LinkedIn, Collection 1, and so forth. But you'll be able to see the scale. Actually, let me full screen that for you there. And I'm going to let that run for just a couple seconds here. And I'm going to pause that. All right. So right up here, we can quickly see that we were able to get 139,494 results in our initial query to start with. And that's everything from dates of birth to like IP addresses to hashes and plain text passwords, as you saw the red go by. And that yielded 22,000 hashes total. And of the 22,000, only about 3,000 of them are actually salted. So we're seeing that once we get, or basically once we take combo listing and target like a bigger organization, we find that the password security of other people is actually like way worse. So Lockheed is probably doing everything they can do. I know from experience in the Air Force that they use like 2-factor on everything, sometimes 3-factor, and you have to use like the smart card and all that to access a lot of their systems. So it's a pretty significant number of hashes, and as we'll see here, once the combo list completes, it's just going to keep running. I'm actually going to have to skip forward, and it's just going to keep going and going and going and going. It only takes about like 4 minutes for it to go and get through all these. So at the end there, what we see is we actually cracked a significantly higher. Instead of like 3 out of 200, now we cracked 7,000 out of 22,000. And so this is mostly because the data that the breach for at least this domain came from is like MD5 and SHA-1, so they're relatively easy to crack, and also they're easy to rainbow table because most of those hashes were unsalted. And actually, when I looked at this, most of the ones that we did compromise, the hashes there, were just rainbow tabled because they were the unsalted ones. We barely got any of the salted ones. So definitely salt your hashes. It makes a huge difference. And it's a shame that Active Directory doesn't do that. So in all, we ended up with 6,349 unique username and password combinations. Now when you look at the scope of a large enterprise, that's 6,000 something accounts that I can try on every single authentication inside their entire organization that faces the internet. That's every FTP server I can find, basic auth, router, big F5, whatever, load balancers, anything. And so it becomes a really big issue because not only can we do that on their network, we could do the same thing we could do with a small organization. We could target GitHub accounts, vendor accounts. If they use a specific fuel supplier, might as well try this list on that. And so the problem can start spiraling out of control really quickly. All right, let's get back to our slide deck here. All right. So this really highlights the systemic problem, and that is, are you triggering your incident response when someone else gets breached? And we actually saw the industry do this in the LinkedIn breach. There was 6.5 million plain text credentials leaked by some other guy, some random hacker went and compromised LinkedIn and then dumped it out there, and they were storing a combination of hashes and plain text passwords. Then somebody I wouldn't say somebody, but then hackers out there started using tools to go ahead and stuff these credentials into like different enterprise networks, and it created this huge ripple effect of hacks out there. And there was like news articles at the time way back then going, oh my God, reset your passwords now, because there were people actively exploiting this, and the entire industry responded by triggering their incident response and resetting their passwords internally inside of their networks. And so that's what's required. The problem is now that we haven't really, as an industry, started doing that again. What ends up happening, other than maybe like the big one, like Collection 1 or something, or when Dropbox happened, we'll see it happen then, but not the little tiny breaches, like little PHP BB forums that like end up on Tor somewhere and it has 3.4 million users, and like sometimes it might contain some enterprise accounts in there and passwords. So, and that's really because of the challenges involved with having to trigger your incident response every time there's a big compromise of a company. It happens all the time. So incident response teams also must be pretty proactive in resetting breach credentials before they're abused, and that's not easy to do. As we've seen with the Wikipedia page from earlier that I mentioned, that the amount of actual reporting on all this is relatively low. So we're not able to really understand when things are being breached, and it's also very difficult to be able to audit your passwords faster than they can go ahead and spray them at your network. And also, incident response teams must be able to respond anytime someone else gets hacked anywhere. Obviously, that's not very realistic. And we have a phrase in our red team, and that's there's only 2 types of networks: those who have been hacked and those who know they've been hacked. And oftentimes, as we saw, there's by the time it ends up on Tor or any of the darknet forums, it's the breaches sometimes are like years old, and that's only when they're discovered. So it's not really realistic. We need a solution that can basically intercept these dumps as they happen, and basically intelligence of getting in and getting these credentials basically made available to the industry. So there are some solutions, thankfully. The industry does try to collect these dumps. They often pop up for only like sometimes hours, and then they're gone, and no one ever has them again. So you have to like ask someone, like, hey, did you get a copy of this breach? Collection 1 had that problem. It like popped up for like a little while, and then it disappeared, and then you had to go and find someone who had a torrent of it or a backup of it. And then it reappeared once someone else started reselling it for cheaper. And so there's basically a growing community around collecting breach data and making it available for enterprises to use to audit their credentials, either their user databases or something like Active Directory. Databases.today is a great one. They host just piles of leaks. I think they have about 2,300-ish breaches, different individual breaches out there that you can just go and download. I think it totals about 3.8 billion records or so. Also, there's Troy Hunt. He has released millions of compromised hashes that you can use for auditing your network, and the links to both of those are up there. So one thing to note about Troy Hunt's data, though, is that it only has 555 million out of it. He has like 8 billion records or so, same as us. But about 555 million of those are actually available in his API. I'm sure he's probably working on making that available for the rest of his data set, but for now, we're kings. We've got 8 billion documents ready to go, and we also have 2.5 billion unique passwords that we've added to our Rainbow table, so they're already available on our API. And so really this highlights the need for industry tools that can adapt very quickly and basically gain that and make available this leaked data to people in a very quick pipeline. And that's what we've built out of our research project. So Nebulous Active Directory is our free open source tool that anyone can go use. And its purpose is to just automatically audit your Active Directory for any leaked credentials. That's exactly what it does. So now it's time to demo that. And this is going to be the help option up there, but while I go ahead and get the video ready for you guys. So there I'm just typing into the command line some options, and snap would be snapshot. That is the easiest way to use this. It uses NTDS utils to just go ahead and grab a snapshot of your DIT file and your system registry hive, and I'm going to actually pause that. So what I'm actually doing is I'm telling the tool to grab a snapshot, shred the files with 7-pass overwrite. It uses sdelete to do that. So it's a sysinternals tool, so that's why it's a more trusted method of doing that. And then I'm also instructing it to grab the user status for the output and also the time their password was last set, which could be useful to you. It's not optional. You can literally just do snap check, and it will go ahead, snapshot, and check and audit your network. It's pretty much 2 commands, and it's ready to go. So I'm just going to go ahead and let that run there. And so what it's doing now is it's going to go into the system registry hive and grab the AES decryption key for your Active Directory database. Yes, it is encrypted, but any hacker can do this just as easy as someone trying to audit your stuff. So one thing to note there, and now it's actually going in and decrypting your or at least our domain's DIP file. And it'll take a second for that to run. It's almost done. Once it decrypts the DIT file, it has to defragment it. And there's lots of techniques about that. Actually, I need to pause that. So I'm going to rewind that a little bit. So we're using InPacket on the internals there, and I'm just going to explain a little bit about the color options there. The gray users here are going to be the disabled users in the domain, and then the blue ones are just what accounts, test accounts I loaded into our test domain that are active. And if I oh, wait, I don't want to rewind. I want to let it play. Sorry about that, guys. So as it goes, again, like the previous tool, red is dead. Those are compromised accounts, user accounts that are in the domain. It's actually checking it against Nebulous's API right now. And it's identifying that those users' actively set password is appearing in leaked data. Oh, sorry. I'm going to get that last bit there so you can see that. And so at the very end here, we can see that 6 out of the 206 accounts have been identified as having leaked credentials, and then we output the result to a CSV file. All right. So there's some great benefits with this tool. We can integrate very easily into existing tools like SIEM, syslog, etc., to alert you in real time about your compromised credentials. The way we can do that is actually every time it audited one of those accounts, it created an audit success or audit failure event inside the Windows event log. Meaning if you're pushing logs from your domain controller to some kind of logging solution, which I don't know anyone here who wouldn't do that, unless you don't want to know who's logging in and out of your network, you're able to trigger an alert based on that event. We can also set this with the task scheduler. This was actually designed to run in the task scheduler to be completely automated. So it's like set it, forget it. And you can just audit your network and set intervals of like 1 day, 1 week, or whatever your security policy decides to do with it. You can combine it with your own scripts to actually take automated action. So you can actually lock out users' accounts or force reset on next login, et cetera, based on the event. So like when you see it, you can actually tell the task scheduler to do it when you see this, like disable this account. We didn't build that into the tool for now because every enterprise is different and they may not want to impact their user. If they automatically like lock the account, that user will just, every time that tool runs, will get like locked out and won't be able to access resources. But you could do things like forcing the password to reset on their next login and so forth. We built this in Python, so it is open source, so you can just go and like inspect it, do what you need to do, make any changes that you want to it. And if you do make changes, be sure to like push the branch upward. It'd be pretty cool to add features in. I don't mind. And but we can run it without the Python interpreter as well. I actually have a compiled release for this. That way you can just download it, set it up in Task Scheduler, and get that running. It's pretty sysadmin friendly, so you don't need to have any technical skill involved with setting this up and needing to know how to really deal with like coding and everything like you would with auditing, say, the torrent file from Troy Hunt, which contained like 555 million in TLM hashes. And there's also no need to store terabytes of hashes to audit. Like our data set is like 13 terabytes or something of leaked data. So it's pretty unwieldy. It takes us like almost 2 weeks to re-index this thing in Elasticsearch. So it takes away having to have that overhead off you guys of having to manage that. Also, we can output to a universal format. We output to either CSV or JSON. So if you can develop and you do want to do more with the output of this, you're able to just, once the output is generated, just grab the CSV or the JSON file and feed it into like Logstash or something. And there's lots you can do with that there. We also are using a familiar library. We built this on top of InPacket, and so if you've used InPacket before, you can use our tool. So I'm going to talk now a bit about what actually the tool did when it ran. So first, it clones the ntds dit file in your system registry hive using ntdsutil.exe that's built into Active Directory, and it will create an exact copy of your database. So you can't actually go in and like decrypt the live database. It's like locked. Even if you're like into authority system, you can't gain access to that. You have to use a volume shadow copy to gain access to that. Inside the system registry hive is your decryption key. We're actually going to take that and then decrypt the database, as I mentioned earlier, and iterate through there and be able to gain access to the NTLM hashes that are in there. Once we have access to those hashes, now we can do whatever we need to do to process the user's authentication data. And at this point, you don't have to use our API. You can actually just output the results from CSV or JSON and then audit them yourself with your own data. You can go on databases.today and go ahead and download all of the different dumps and everything and create a rainbow table of your own. I do want to note, though, that that is a major pain to do because the way that the data is basically stored, it's a very weird different formats. Every leak is different. Sometimes you get like straight SQL map output. Sometimes it's like a CSV that's like with a weird delimiter. And so you have to parse each individual data breach. And there's like thousands of them. So it takes a long time to do. And so if specified, if you specify the check option, we will go ahead and check these against NewID's API by wrapping them in SHA-256. So obviously we're not going to have the NTLM hash sent over the network. That would be crazy to do that. So we created a special rainbow table in our rainbow table that has all of our NTLM hashes wrapped in SHA-2. That enables us to check hashes without needing to like send the actual NTLM hash over the network. And so once we get that, we wrap it in SHA-2 and it does HTTPS get over to the API. And the API will respond with 200 OK. The hash is there. 404, hash not found, as in it's not found in our data set. So if you get a 404, your hash is safe. If you get a 200, yeah, it's compromised. It actually has a JSON output saying it's like whether or not it's in there. So, but you can just do it purely off of the status code. That way it's a lot quicker. You don't have to parse JSON and deal with the deserialization overhead. And then, of course, once we have the result, we log it to the Windows event log and then dump all of the results to the specified output if you want an output result of that. And this is what it looks like in the Windows event log. So you'll see there that the source is nebulosad.exe. It's just the name of the exe file. We have our event ID, which is just 4141. And here I'll go ahead and highlight those for you. So I want to point out that if you do make an SIEM rule, what you want to do is grab that extended information because it'll actually, that's where we store where the account or which account is compromised in there. So if you make a rule, you want to grab that additional information so that way it's available in your dashboard when you get an alert. And of course, we use audit failures or audit successes to do that. That's the bottom right arrow, and then our event ID there. Now, the user that you see there is just what user in my test domain ran this, in this case, the local administrator, because, you know, it's just a demo. And then the computer, or in this case, the domain controller it's ran on. This is useful so that way you can audit what system is actually auditing all of your passwords. It'll tell you the user and the machine that did that. So I want to talk a bit about what we're doing in the future. And for now, we're stuck on Python 2.7. Unfortunately, that's due to limitations within Impacket. We're actually looking at porting to 3.7 soon for that very sweet async functionality, and hopefully can get that done before the end of life date. But Impacket's a massive project, and they still haven't ported it, so we'll see. No promises there, but I definitely want it to 3.7 because if we get async, we'd be able to audit like 50,000 users in a second, and that'd be really cool. Also, more data. We're always adding data to this. We started out at the beginning of December with like 5.4 billion, and now we're creeping closer and closer to 10 billion. We had like 8.3 billion that I mentioned. It was the actual document count in Elasticsearch. But there is a lot of data I haven't indexed yet. So we're always adding more data to this, and we're always just going to keep throwing more stuff into our rainbow table, and that's going to be available to you guys for free. Next, we want to do is actually permutate all the passwords. And the reason you want to do this is because hackers are doing it first off, but it'll catch policy violations from people who just do really basic stuff like if they have MyDogSpot 2018 and then they set their password next time to MyDogSpot 2019, you're going to catch those policy violations. You'll catch those users. And so we want to permutate the entire data set looking for patterns like that. And yeah, it's a lot of work. And when we tested out doing this before, it was like estimated it was going to end up being like 50 billion additional hashes added to it. So it'll be quite a lot. But it'll catch any of the permutated passwords from tools like Crunch and so forth. Also, easy mode sim rules. I didn't get any built in time for the talk, but I definitely want to release some. We use Security Onion internally, and so I can release the dashboard and the rule set for that, so that way you can just import it and it's ready to go. You can also do that same thing in McAfee Sim and ArcSight, and those are the two that I'm aiming to create a rule set for. And if anyone has any other like SIMs that they want a rule set for, then just like message us on, just either email us or make a GitHub issue, like raise an issue in GitHub, and like I'll totally try to make a easy mode a rule set for you guys, so that way you can just import it and it just works. And then for the very thick tinfoil hats in the room, I also want to mention that some of you guys don't like the idea of SHA-256 wrapping the NTLM and sending it over. Troy Hunt's API has something called K-anon or K-anonymity. That's where he actually uses the NTLM hash. He just takes the first like 5 characters of it and sends that over. What you get back as a result is like a list of 400 to 500 hashes. Then you have to iterate through all of those to figure out if there's a match. And that's kind of an inefficient way of doing that. And we at New ID actually kind of specialize in zero-knowledge cryptography, and hashes are actually really, really great for using zero-knowledge proofs on. So we may go beyond K-anon and instead just use, instead of just wrapping that in SHA-2, we may just use zero-knowledge proofs to do the check. That way you're not transmitting either hash or any part of the hash. You're just transmitting something that can be used to verify whether or not we have that in our data set. And then the last one is hopefully we can get an API to check user credentials during registration. This is just for, this tool is just really for Active Directory, and that's like a very static data set. You have just your users in your environment, and they're not really too many added or removed unless you're a very big organization. So it also doesn't really cover someone out there running like WordPress or something, and they have like 3,000 users. So there is a way that we could expose a check during registration, so that way we can check the user's credentials as they're being registered on the site and say, no, password 123 is like terrible, please don't use that. So there is some known issues that I would like to point out, because Impacket has a bug when dumping NTLM history on some builds, not all. I have a GitHub issue raised with them there. The link's there, so you can track it if you want. And what that is it's only for the history. So you can still check the actively set password. That works just fine. But you won't be able to check the history of the user. And I only really encountered this on server 2016 and 2019 in AWS, not when I installed it on hardware. So who knows what that bug is, but if you do encounter that, just let me know. You can either raise a Git issue or just wait until I can figure that out. And also the pre-compiled binary can be slow to start on some systems, and that's just the way it was compiled. And I tested this on a dual core 4 gigs of RAM AWS instance, and honestly, unless your domain controller is running on a potato like that, then you're not going to have any issues, because it took like 5 to 6 seconds for it to start up and then go, but that's on a dual core. So if you're running actual physical hardware, it'll go right away. And the application is multi-threaded, so it'll take advantage of those cores. And again, of course, any issues, raise them up on GitHub. So here's the link to the repository there, and I don't know if we have time for Q&A or not. I think we do. I think I'm way ahead of schedule. Got like 15 minutes.
Yeah, we have quite a bit of time for Q&A.
Yep, and I'll be available after this to come talk to and everything. Me and my colleague Ibrahim. Oh, he's right over there.
Hi, how's it going?
Yeah, it's good.
Great presentation. Quick question I had for you was, how do you guys feel your database compares to, say, Azure AD password protection service that they've recently brought out of beta, where they're checking against their own tools, but they say they're not using anybody's outside data. So I'm assuming they're doing their own magic, but does anybody know kind of what their repository looks like in terms of known compromised passwords?
Yeah, as far as I know, most of the people that I've seen, they're collecting stuff from publicly known sources such as database.today and any of the newest stuff when people started building these services. So really that's going to be data dumps that have appeared since like 2017. We've been collecting stuff since like 2009, and we have data that goes back to 2006, and we also have data that hasn't appeared anywhere else that we know of. It's not in Troy Hunt, it's not in anything. Like when I check my own email and everything, I see stuff that Have I Been Owned doesn't have in there. So in all, the amount of data breaches we have is 7,700 and something individual websites. Those aren't even the pay spins. So it's quite a lot of websites that are in there, and I'm not sure how many Troy Hunt has. If I recall, it was like 2,000 to 3,000. I don't know. I'd have to go and look. He actually has this data sets available. One thing that we do want to do is make which databases we do have available. So that way there will be a list. That way you could just compare it to different services. But we offer this API for free. You do need an API key, as it'll say on the GitHub page, and the reason for that is so we can like enforce rate limiting and everything. But other than that, yeah, you can use any of those services. Since the tool itself does dump to the NTLM hashes for you into like a JSON or CSV, you can make your own tool set or expand the existing one. Just clone the repo or something and like build your own check against those services.
Question here. You mentioned the zero knowledge proofs and the distributed ledger for availability. My first reaction there was, is the ledger available publicly? Because that would be how I would see it being.
Oh, are you referring to a new ID solution? So this tool doesn't use the distributed ledger. I would just use zero knowledge proofs within our own internal data set to make it so that way you can transmit it like the most secure way possible to check if the credential is leaked. But new ID solution, yeah, we do use distributed ledger for that. That's Ethereum, but that's kind of out of the scope of this talk, I think.
Okay.
You can come talk to me and Ibrahim afterward for that.
Anybody have?
Yeah, right up front here, you had one.
If I'm understanding correctly, it's making API calls back to your server to check, hey, has this password been compromised, right?
Yes.
How can I trust that you're not doing something nefarious with what I'm basically saying, hey, these are my passwords?
Yeah, so that's the unfortunate thing. Actually, Troy Hunt made a very good case for that. That's why he made KAnon. That's also why we want to either adopt that model, just with the SHA-256 wrapped version instead. So that way I only see like the first 5 characters of a SHA-2. And that's going to return quite literally probably 10,000 results. So I might have to bump it up to like 7. There's a medium in there. So that way I'm not aware at all of what the heck hash you queried. It could be one of hundreds to thousands. Now, though, even KAnon, though, when I looked at it, I was like, really, though, that you could be able to figure out. You'd look at the incoming queries, right, and you'd be able to see that, okay, you can grab each individual list from the query, and now you basically have a combo list. A lot of those will fail, and some of them won't work entirely because if it's not a direct match, of course, but you'll have the list of what they queried with KAnon. With the zero knowledge proof, there would actually be no way for me to check what the heck you just queried. It's just the way that zero knowledge proofs work, and if we did adopt that into the API, then that's what I would have well documented on how that works and how we can't check it. But you could just, as I said, you don't have to use the check argument in there is is separate. So you can actually have that disabled, or you can go in, code in the repo, and when you compile it, just literally just remove the argument out there entirely. And I put the API callbacks in there into its own separate class. That way you can just literally highlight the class, backspace it, and there no more check. So, yeah.
Hey, I have a question over here. Right over here.
Oh, yeah,
There you
I
go.
see.
So I'm guessing, in my experience, to get the NTDS DIT, the only way to get it is from a domain admin. Do you need to run this tool with domain admin?
Yeah, you would need to run this tool as something that has domain admin, or as something with local administrator privileges on the domain controller will work as well. That's just the way that it has to be for NTDS util to have the right privileges.
Thank you, and this is just a confirmation. Before I send the file, I can edit and remove certain hashes for known accounts of mine. Is that possible? So I edit the file before checking. So for instance, curve.gg is I'm not sending the hash for that.
Huh. Actually, the way the check function works is it just grabs the diff file and then just immediately starts checking. That's actually a good point. What I'll do then is make it so Impact has the way to just point to a dit file. Actually, I already have it in there. You can point to an offline thing. So I'll probably just actually make that a feature and modify it to be able to do that. It's a good point. Yeah, but currently, no. Yeah.
Were there any more?
Whoa.
Were there any more questions? I don't even know where the speaker was up there. All right. Well, thank you for coming to BSides, and thank you to Robert for his wonderful presentation.